This is the solution set for the stats homework, page 44, 1, 2, 5, 8, 11, and 13. Number 1 is about education. I like to start these by taking all the information from the paragraph and converting it into a nice table. I'll show you what I mean. Here's the information given in the paragraph. $16.1 thousand a year if you have 9th grade education, $34.3 thousand a year, 12th grade education, associates, bachelor's, master's, PhD, with all the corresponding average salaries that you would start with. We need to do a bar graph for these. So what I'm going to do is with a bar graph, bar graphs are different than histograms. Bar graphs are good for nominal data. That is, this is just names. So I'm going to put the different educational levels at the bottom. And PhD. Then we have to take these vertical, or the dollars will be vertical. And so we have, let's see, I'm going to make that a little bit taller. I'll make this maybe 100, which will make that 50. I'm then going to cut this into 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And now I can make my bars. Now for a bar graph, the bars typically don't touch each other. I'm going to go up to 16, which is about there. I like to put the number on top. It makes it clear. And then the next bar is going to go up to 34. 0.3. Associates goes up to 48, almost 50. 48.6. Bachelor's goes up to 62, which is up to about there. Master's 71. 50, 60, 71. And finally, the PhD goes up to 84. So somewhere around there. 84.1. And there is the bar graph. In question number 2, we're given data in different countries, the number of children that die of accidents per 100,000 children. So again, what I'm going to do is write out all my individual information, right, and then I can organize it. So here's all of the information listed off so I can see it clearly. Now we're doing a what's it called? Pareto chart, sorry, which means it's a bar chart which is in descending order. So we need to pick out the biggest number, which it looks like it's 25.6. Doesn't really say whether that's North or South Korea. And then it looks like the 19.8 might be the next one and down. You know, with such a large list of numbers, it's going to be easy to make a mistake and miss one. So what I'm going to do is I'm going to go over to my calculator, go stat and edit to get into my stat lists. And I'm just going to start typing in all my data, and then I can sort it and it'll make it much easier for me. So here I've typed all my data in. So what I'm going to now do is I can quit out of this. I'm going to go back into my stat, and here we have sort ascending and sort descending. So I'm going to go to sort descending and give it my number 1. And then I'm going to be able to go back and see the sorted list by hitting Stat, Edit again, and there you can see my sorted list. And now this is going to make it much easier to tick off the right one in the right place. What I'm going to do is I think put a grid up so that it'll help make the bar graph. So here's my grid. Hopefully that should make it a little bit easier, and I can draw my axes along the grid lines. Let's see if I can do that. Now I see my biggest number is 25, so maybe I'll go by 2 blocks is 5, 10, 15, 20, and 25. And I'm going to just have to tick off all the individual countries down the bottom. And so what I'll do, this is still a bar graph. The first one is going to be this 25.6, so that's going to be Korea, and that goes up above here. So that's going to go 25.6. I'm going to make it very narrow because I know I have a bunch I have to do. And what I'm also going to do at this point is keep track of which ones I have already taken care of. That way I can know I've accounted for everything. Actually, maybe what I'm going to do is cross it out that I've done it. So I'm going to continue and keep working at these, and I'll show you the end result. Here's a little progress, about halfway. I just did France at 9.1. After 9.1 is 8.4, which looks like is Japan. All right, so here is the Pareto chart. I filled them in to make that look all pretty. And you can see it's in declining size of bars, which is what you're supposed to do for the Pareto charts. Now we're going to be doing question number 5, which is about where people stash all the mess when someone's coming over. And again, I'm going to be listing off the data so that's a little bit easier to see. Here's the information. 68% stash stuff under the or in the closet, sorry. 23 under the bed. In the bathtub, that doesn't strike me as a good place because people can see that. And then in the freezer, not much space in the freezer, so you can't stash too much stuff. We're supposed to do a pie chart. And the way I usually start is with the largest, which in this case is 68. And I know that 68%, well, that's very close to 2/3, 66. So I can guess at where 2/3 is. 1/3 would be about here, so 2/3 is about there. So there's my 68% in the closet. This next one, 23, well, that's very close to 1/4. I'm going to actually start from this nice vertical line I started with, because that allows me to do that 1/4 pretty closely. Approximately 23% under the bed. And then this last little piece here, 6% is twice as big as 3%. So I can split it maybe like that. There's 6% in the tub and 3% in the freezer, if you can read that. Now there's no particular order, right? Closet, bed, tub, freezer. I could have, just as easily put the bed down here or rearranged it. That doesn't make too much difference. So there's the pie chart. Now we're going to move on to number 8, which is about how old college professors are. Here's the data, the information. We're supposed to make a pie chart again. So start off with our circle. Not a bad circle. Now we have ages. Now ages do kind of go in order. So you would want the pie chart to be organized with the adjacent ages actually adjacent to them in the pie chart. So we do need to keep that a little bit in mind. We can kind of start off seeing if we can use the same method I did before. Here's the biggest one, 37. That's a little bit more than a third. So maybe I can estimate about a third, a little bit more. There's our 37%, which is 45 to 54 years old. Now I notice this next one, 13, well, 37 and 13 put together, well, that's 50. Well, that's very convenient, and it's the next pie piece here. I can just drop that right down, and here we have our 55 to 59-year-olds, which is 13%. So we've taken care of that one, we've taken care of that one. The next biggest one is actually going another direction. It's a little less than a third. So again, having this nice vertical line to work with helps. So here's, a little less than a third perhaps. That's going to be 29%, which is 35 to 44 years old. You can see that I'm maintaining consecutive ages next to each other, so that's good. And then we have, working back this direction, we have an 8%. Coming around this direction, we have a 9% and a 4%. Well, 8 and 9 are about the same, 4 is about half. So maybe I would divide it kind of like that. That looks decent. Maybe go a little bit more. That looks pretty good. Here's our 8%. Here's our 4% and our 9%. The 9 being 60 to 64. This is 65 and up. And this one is the other end of the spectrum, which is less than 35. Not too many professors less than 35. And so let's get rid of those. We've done all of them, and we've actually maintained the consecutive order of them, which is good. Now we're going to move on to question number 11, which is about Pyramid Lake in Nevada and the level of the water as it changes over time. They present the information in the textbook already in nice tables, so I'm not going to reproduce those tables for you here. But we can go and make our axes. All right, we're supposed to be making a time plot of the information, which makes sense because it does vary with time. And of course, one of the tricky parts of this is figuring out the scale, and what I'll do looks like going from 86. If I go from 85, it's in even increments. Maybe I'll just go 1 year per square. 86, 87, 88, 89. So that would be 90. 95. And 2000. That fit very nicely. And then I'm going to start. I can actually even do this. I'm going to make a break in the axes. Different ways of showing that, but I'll do it that way. So we'll start here at maybe 3795, because there are no lake levels that are less than that. And then maybe we'll go up by 5s, maybe every 2 blocks. That seems to fit fairly nicely. So this would be 38. Yeah, that seems to work. Now I'm going to start plotting this information. The first one is 1986, which is here, and 3817, which will be, 2.5 is 1 block, so it'll be a little less than 1 block. And we're just going to make a dot. And I'll put the rest of the data on now. And here is the time plot. You can see that somewhere, in the 90s, the mid-90s, the lake went down quite a bit and then seemed to recover back to its previous level. Now we move on to question number 13, which is a very interesting question. We're looking at the stock price for Coke and McDonald's and how they vary over time. They actually give you 2 moving averages, which are very useful. The 50-day moving average is, of course, the last 50 days, and it's called moving because, tomorrow it'll still be the previous 50 days, which will be a slightly different 50 days. Now, the 50th day from yesterday will no longer be in the average anymore. So the 50 days moves as time progresses. And, of course, the 200-day moving average is the same thing, only the last 200 days. The longer you average, the more you combine all the pluses and minuses. Stock goes up, stock goes down. The longer you average it, the more it smooths it out. So it asks you to kind of compare the two. So what I'll do is put my solution up. So here's my solution. The question asks, comment on the volatility and performance difference of the stocks, which declined by the smallest percentage during the period shown. So what I did is I started off by saying, all right, well, let's get the percentage difference. And it's graphical, so I just had to estimate what the starting stock value was and what the ending one was. And I subtracted, and these are actually negative because it's going down. And we have, it went down, $5. And in fact, McDonald's went down by $5 also, which is kind of interesting, approximately. Now, you can see that the value of the stock itself, however, is quite different. So the percentages are quite different because $5 on, 52.5 is a smaller amount than $5 on 34. So we have 9.5% and 14.7%. So of course the smallest one would, by percentage, is 9.5%. Although the difference in terms of dollar value of the investment is about the same. And my analysis of the performance and volatility, I typed up. Coke exhibits greater volatility than McDonald's, as can be seen in the 50-day moving average. Right? Coke's 50-day moving average just shows much more swings up and down. Right? But the longer 200-day average shows a different picture. It might be more volatile, but you can actually see that the longer average, the 200-day average, seems to smooth out quite a bit, which means that the swings up and the swings down balance each other. Right, so over the long term, it's going to be about the same at the end than the beginning, which is, I suppose, perhaps why we have a smaller percentage. Now, McDonald's has a clear downward trend through its 200-day moving average. You can see it's got that constant downward. And so it may not have as much, smaller swings, not as much ups and downs. It's just a consistent decreasing, which of course is not exactly what you want. But of course, the question, which wasn't asked, but whenever you do this financial kind of question, is, where do you invest your money? And it sounds like McDonald's would be a bad investment, right? Because, it's declining, it's declining. Of course, you want to buy when it's low, right? That's when you make your money. So if it turns around, this might actually be the perfect time to buy McDonald's, if you think it's actually going to turn around. Where, for Coke, consistency means you're not going to really make as much money with Coke. So it really depends on your interpretation and what you think the future is, because future performance is difficult to determine by past performance, because it's a chaotic system. Things change. The board of McDonald's is looking at the same data, and so they're trying to figure out how to make changes to make things improve.